Our next lesson in our completing the model of the atom unit is on using noble gas notation to write electron configurations. So I just want to start with an example of what we mean by noble gas notation. And as you'll see once we do it, it really is just a shorthand way of writing electron configurations where we don't have to show every single electron in our notation, which would make our job easier. So we're going to start by writing an electron configuration for krypton, which is a noble gas. Here's a periodic table, and I like this periodic table for writing electron configurations because, as we did in class, it shows us each block, S, P, D, and F block. And not only that, but it shows us which sublevel is being filled. So notice krypton here is at the end of the 4p block. So we know it's going to end with 4p6 because it is 1, 2, 3, 4, 5, 6 elements into that 4p block. So recall what that means is everything then before that will be filled. So that would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. And that would be the electron configuration for krypton. Now we're going to write an electron configuration for tin. So notice tin's position on the periodic table. Here it is, atomic number 50. Notice it's also in the p block. It's in the 5th period. So we'll end with 5p. And it's 2 elements into the p block. So it's going to end with 5p2. So everything up to 5p will be filled. So it'll look very much like krypton's. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. So notice up through 4p it is exactly like krypton. After 4p, now we're here with the 5s, so it'll be 5s2, 4d10, 5p2. So to point out again, tin's configuration is the exact same through that 4p sublevel as krypton's. So what we can do is we can simply use krypton's configuration to say tin's is just like krypton plus this additional stuff. So whenever you see this notation, the brackets with the symbol for the element, what that means is simply that is krypton's configuration. So when we see this, the brackets and the krypton, the symbol for krypton, that means this configuration right here. Notice that is exactly like the start of tin's configuration. And then we can just show what's left. That would be the 5s2, as you can see here, 4d10, 5p2. So again, that notation with the brackets and the symbol, that simply means krypton's electron configuration. So the point of all this is whenever we use noble gas notation, it only shows electrons beyond the previous noble gas. So for example, just to reiterate this one, we wrote tin's electron configuration. So we go to the previous noble gas, so in other words, the noble gas from the period above it, so that would be krypton. And we say, okay, tin's going to have krypton's configuration plus whatever comes next. Now, sometimes students are a little confused by this because they might say, wait, how does this make our job any easier, any shorter if I have to write out all of this stuff here for both these configurations first? And you absolutely don't have to. Because we understand how the periodic table works, we know krypton's going to end with 4p6 because of its configuration. So we just pick up with whatever is after 4p, which we know, based on the periodic table, is 5s. So we're going to see several different examples here. Same sort of thing. I'm going to give you this same periodic table here, and I'll just talk through each example. If at any point you feel like you understand this, just pause the video, try the next one yourself, and then play it and see if you got it right. Alright, so the first one we'll do here on this page is silicon. So what I want to do is I want to find silicon, and here it is, atomic number 14. And if I'm going to write its configuration using noble gas notation, I need to find the noble gas from the period that comes before it. So in other words, the period above it on the table. So that would be neon. So I'm going to put neon in brackets, and do note it is brackets, it's not parentheses. We want to use that square bracket, that is the notation that gets used. And then we write the symbol for neon. So what that means is silicon is going to have neon's configuration plus whatever comes next. Now note, neon is at the end of the 2p block here, so that means it's going to end with 2p6. So we'll pick up with what happens after 2p. Well, that would be 3s. So silicon's configuration would be neon plus the 3s2. You got those two right there. And then we need two more here for this 3p block, 3p2, because silicon is two elements into that 3p block. All right, let's look at another example. Cobalt. So again, we want to find cobalt on the periodic table. Here it is, atomic number 27. Okay, notice it's in the D block. It's in the 3D block. So it's going to end with 3D, 1, 2, 3, 4, 5, 6, 7. It will end with 3D7. As far as which noble gas to use, I need to go to the noble gas from the previous period. So that would be up here, argon. Okay, so I'll start my configuration by saying cobalt has argon's configuration. And remember, argon, we can see here, is at the end of the 3p block. So argon's configuration ends with 3p6. So we'll pick up then with 4s. So that would be 4s2, 3d7, because cobalt is 7 elements, if we count over there, 7 elements into that 3d block. All right, radon. Radon is itself a noble gas. So you might be saying, well, I should just put the symbol for radon in brackets, Rn, and call it good. That's not how it works, though. Even if we're writing the configuration for a noble gas, we still always use the previous noble gas in the notation. So the noble gas that comes previous to radon is xenon. So I put the symbol for xenon in brackets. And note, xenon's at the end of the 5p block here. So that ends with 5p6. So I will pick up with 6s. So that would be 6s2. And then after that is 4f14. So remember, after this 6s here, we're down here into the f block. And remember as well, you can use that northeast to southwest rule chart to help you remember the order as well if the periodic table isn't convenient for you, or if you would just rather use that chart, by all means do that. So we have 6s2, 4f14, and then we have 5d10 that takes us across here. So now we're here to the 6p block, and that would be 6p6 because radon is at the end of that, and it's 1, 2, 3, 4, 5, 6 elements into that 6p block. All right, gadolinium. Gadolinium is down here in the F block. It is atomic number 64. This can often be confusing the first time we see this because sometimes it's hard to figure out what the previous noble gas is. Remember that these elements here in the lanthanide series, all these elements are actually right up here in period 6. So gadolinium is actually right in here between lanthanum and hafnium. So the previous noble gas is the 5th period noble gas, xenon. A lot of times students will look at this and they'll say, well, it's radon, or actually now the periodic table has been updated with newer elements. This element right here, which isn't even listed on this particular periodic table, but it is in fact xenon, is the previous noble gas. So that ends with 5p, so we'll pick up with 6s, so that's 6s2, and then after 6s we have 4f, and we can count over 1, 2, 3, 4, 5, 6, 7, so 4f7, and we're done with gadolinium's configuration. And then one more here on this particular page, we have fluorine. The reason I want to put this one on here is oftentimes students way overcomplicate this. The previous noble gas from fluorine is helium. Okay, and what will make students get confused, or we'll get worried about it, will be, well, helium isn't even in a P block. It's it's in that 1s block. In fact, a lot of times we'll think about helium being over here. So does that mean I can't use helium? Well, no, absolutely not. It's still a noble gas. I put helium symbol in brackets, and just understand that its configuration is simply 1s2. So after 1s2, I would pick up here with the 2s. So that would be 2s2, and then fluorine is 5 elements into the P block there, so 2p5, and we're done with that configuration. All right, one more page here. I just want you to do the same thing here for each one. I'm going to show you the element, pause the video, write the configuration yourself, play it, see if you got it right. Alright, first one to try is arsenic. Arsenic's noble gas configuration, you'll notice it's going to end with 4p3. The previous noble gas is argon, so we'll start with that. And then we want to make sure we see that argon is going to end here with 3p6. So we'll pick up here with 4s2, 3d10, 4p3. Now try uranium. So the previous noble gas to uranium is radon. Okay, here's uranium down here, atomic number 92. So it's here in period 7. So the previous noble gas is the one from period 6, so that would be radon. And that ends with 6p6. So we'll pick up here with 7s, so that would be 7s2. And then we can count over. Uranium is 3 elements into the p block and f block, and we get our configuration. I just recognize here that's actually an error. That should be 5f4 is what that should be, because actually actinium here typically appears at the front of the actinide series. So I have a typo. That should read 5f4. If you're looking at your periodic tables that you typically use, you'll see what I'm talking about there. That should be 5f4. All right, and finally we have mercury. Mercury's configuration. The previous noble gas is xenon, and xenon ends with 5p6, so I'll pick up with 6s. So that would be 6s2, 4f14, 5d10, because you'll notice that Mercury's configuration or its position is 10 elements into that 5d block.